Assalamualaikum and good morning to Dr. Jagan and Dr. Lob. My name is Nurji and we are from Group 6. We'll present our study regarding inland ports and seaport decarbonization. Our group consists of 8 people, two people from maritime management and 6 people from computer science with maritime informatics. Now, the first presentation that will explain the abstracts, I will pass to Mr. Afiq from Maritime Management. Hi,
Assalamualaikum and very good evening to everyone. My name is Muhammad Afiq Zarafan bin Zainuddin. My metric number is S70294. I am a maritime management student, year 3. And today I would like to present my part, which is the abstract. As we all know, the maritime transport moved over 80% of the global trade and now is entering the critical transition towards zero emission operations. Both port, which is the coastal seaport and inland dry ports, play a central role in the meeting of the IMO targets of cutting the greenhouse gas (GHG) by the emission by 50% by 2015 from 2008 levels. This study also combined a systematic literature review with a bibliometric analysis using the Vosbuer and Scopus to trace the field development. And the result also revealed three evolution phases. The first phases is from 2021, focus the alternative fuels and technical choices. And the second phases in 2022 until 2023 shift towards the low carbon maritime transport and system level development. And the last one uh, from 2024 and still ongoing is emphasized on the cleaning maritime economy driven by market mechanism and also the green corridors. This process will require integrated approach linking the digital twin with green corridors and also positioning ports as energy hub for both maritime flows and hinterland decarbonization. That's all from me. Thank you.
Thank you, Mr. Afiq. My name is Nurji Alia Al-Buhari binti Ibrahim, S71717, and I will continue with the introduction, background and context, problem statements, and objective of this study. First, I will start with the introduction. These sections will explain why decarbonizing the maritime logistics chain is becoming urgent. Today, ports are not just transit points. They function as energy hubs that must manage emissions and cleaner fuel technologies. The introductions will also highlight the regulatory pressures, technical challenges, and the differences between coastal ports and inland ports. This will help set clear boundaries for our study and prepare the basis for our objective. Thanks. Thank you. Next, moving on the background and context. Maritime transport is essential to the global economy, but it is also one of the major contributors to greenhouse gas emissions and air pollution. Because of this, ports around the world are undergoing a major transformation. They are shifting from traditional cargo handling roles to becoming energy controlling hubs that support decarbonization. Both seaports and inland ports are now expected to adopt cleaner operations, including onshore power supply (OPS) and alternative fuel bunkering. And these changes are driven by international regulations, especially the IMO requirements to reduce carbon intensity by 40% by 2030 and at least 50% greenhouse gas reduction by 2050. So this background helps us understand why ports are under increasing pressures to modernize and move towards greener operations. Now we will talk about the problem statements. Even though regulations are becoming stricter, achieving full decarbonization is still very challenging. Port faces several technical and economic obstacles that slow down the transitions. The first issue is the fuel mosaic dilemma. There is no global agreement on which fuel will dominate in the future. Options like LNG, methanol, ammonia, and hydrogen all have different benefits and risks, making investment decisions uncertain. The second issue is inland port constraints. Inland ports often have limited resource, older equipment, and stricter air quality regulations, which make it harder for them to upgrade and meet decarbonization standards. And the third issue is grid stability and cost. Electrifying port operations and implementing OPS increases the load on regional power grids. At the same time, building renewable-based microgrids require very high investment. These three challenges show why decarbonizing maritime transport is complex and why ports need strategic planning and technological upgrades. Finally, we go to the part objective of the study. There are four objectives in this study. The first objective is to evaluate current situation and maturity of technologies such as EMS and shore power. Two, to analyze key technical, economic, and regulatory challenges. Third, to propose future solutions including green shipping corridors and digital twins. And the last one is to perform bibliometric analysis using VOS Viva to map dominant research trends.
Today I will be present the current progress ports are making in their journey toward decarbonization. This progress mainly falls into three areas: energy efficiency, electrification, and transitional fuels. For, for the first one is energy efficiency as the first fuel. Currently, ports are prioritizing energy efficiency as their first major step. Many ports are deploying advanced energy management system or EMS, which use data analytics to optimize operations. Equipments like key cranes and yard tractors now run on more efficient schedules, reducing idle time and lowering peak energy demand. This shift cuts diesel use and prepares ports for full-scale electrification. The second one is electrification and shore power, cold ironing. Another major status update is the rapid expansion of electrification. Modern ports are increasingly adopting onshore power supply, also known as cold ironing. This allows ships to turn off their auxiliary engines while at berth and draw electricity directly from the port grid, eliminating emissions during port stays. To, to support this, ports are installing renewable energy sources like solar panels and wind turbines, becoming more sufficient and environmentally friendly. Last but not least, liquefied natural gas as a transitional fuel. At the same time, port continues to use LNG as a transitional fuel. LNG LNG engines today are more efficient and release lower amounts of sulfur oxide and nitric oxide. However, methane slips remains a major issue, limiting LNG's long-term role. For now, LNG is viewed as a temporary step while ports shift towards cleaner and fully renewable power alternatives.
Assalamualaikum, my name is MMM3843. Number is I73073. Today I will be representing the challenges to decarbonization. We face three major challenges that are slowing down the progress. The first point is the hydrogen challenge, the second one is fuel uncertainty, and the third one is grid stability and control. For the first point, the hydrogen challenge, hydrogen is difficult to store and use efficiently. It requires huge tank because it contains much less energy than traditional fuel. It must be stored under extreme pressure or at extremely cold temperature, which would require ports need a brand new, expensive infrastructure and safety system to manage it. A lot of energy is lost in the process of making and using it. For the second point, fuel uncertainty. With several fuel options available, it is hard to know where to invest. The industry is split between options like ammonia, methanol, and biofuels, each with its own pros and cons. This creates a major financial risk. If a port invests in the wrong fuel technology, the investment could be wasted. For the third point, grid stability and control. Electrifying ports put a massive strain on the local power grid. Charging a large ship like powering a small town Charging a large ship is like powering a small town all at once. The sudden huge demands for electricity can overload the system and cause blackouts in the port and surrounding areas.
Hi, my name is Atira S72877. In order to overcome these challenges, the way forward for port decarbonization are green shipping corridors. Green shipping corridors emerge as a powerful new model. Specific trade route gain zero emission status. Examples include Shanghai, Los Angeles, or Rotterdam, Singapore lanes. By focusing on a single route, stakeholders can concentrate investment in the necessary infrastructure at just 2 ports rather than trying to decarbonize the whole world at once. Early adopters secure guaranteed markets for green fuels, entry barriers drop fast. Next, ports as hydrogen hubs. Ports must serve wider industrial clusters, not ships alone. By using hydrogen as an energy carrier for the entire industrial cluster, often located at near ports such as steelworks or chemical plants, ports can aggregate demand. These scales allow for the economic production of hydrogen, which can then be offered to ships as a secondary market, thereby solving the infrastructure cost issue through economies of scales. And for the last one is digitalization and pathways. Future ports runs on digital system. AIS-based simulation predicts and cuts ships' emission before they occur. Digital twins and smart grids connect everything. Cyber attacks target these links. Strong maritime cybersecurity becomes mandatory. Multiple fuels will coexist until 2050. Ports must build flexible infrastructure ready for several energy vectors.
Assalamualaikum, my name is Fatina bin Fazil, metric number S72972. Next, I will explain the methodology used in our study. For the data collection, we conducted a bibliometric analysis using the published Operage software. The data retrieved from the Scopus database because it provides wide and relevant coverage of high-quality research, especially in engineering, transportation, and environmental science. Our search strategy focused on study related to port infrastructure and decarbonization technology. We used Boolean search query that covered keywords such as port, seaport, inland port, decarbonization, zero emission, GHG, alternative fuels, microgrid, onshore power supply, and digital twin. The parameter for the data selection were a time span from 2019 to 2025, only journal article, conference paper, and review, and the English language. These criteria ensure that our dataset reflects the most recent development, especially after the latest IMO regulation. After collecting the data, we exported all bibliographic records into VOS Viewers version 1919 for analysis. VOS Viewers is a software commonly used to build a visualized bibliometric network. Two main analyses were conducted. First, keyword co-occurrence analysis. This analysis identifies how frequently certain keywords appear together in the same publication. It helped us detect major research terms and understand how different topics are connected. Second, citation network analysis. This analysis mapped the influential author and key papers with the dataset. It showed the intellectual structure of the field, including major topics like microgrid, alternative fuel, and operational efficiency. These two analyses help us to understand not only what topics are trending, but also who the leading contributors are in the port decarbonization research. Before running the final analysis, we perform data cleaning and normalization to ensure accuracy. First, we homogenize keyword. For example, different spelling and variation of decarbonization were merged into one standard terms. Next, we remove stock words such as study, impact, or analysis because they do not contribute meaningful information to the thematic cluster. The source file was created to unify similar technical terms. For example, infrastructure-related terms like cool ironing, onshore power supply, and shore power birds were grouped into shore power. Energy-related terms such as liquid hydrogen and hydrogen supply chains were merged into hydrogen. while LNG variation were grouped under LNG. Digital terms like digital twinning were standardized as digital twins. Finally, regulatory and economic terms were categorized under policy. This cleaning process ensured that the visualization focused on meaningful research terms instead of scattered or duplicated terms.
If we look at the figure 5.1, the overlay visualization tells a linear story of the last 4 years. First, look at the purple nodes from 2021. This was the first phase. The industry was obsessed with the what. This aligns with the Gray's concept of fuel mosaics. Researchers were debating LNG versus hydrogen versus ammonia, looking for a technical silver bullet. Then we moved to the green nodes in 2022 and 2023. This is the second phase, the bridge. The realization hits that choosing a fuel is useless without the infrastructures. The conversation shifted to shore power and microgrids, ensuring the systems could actually support the ship. Finally, we arrive at yellow nodes of 2024 and 2035. This is the clean maritime economy. We have moved past simple technical feasibility. Now strategy takes center stage. We are talking about green shipping corridors and supply chains. As noted by Songs in 2025, ports are no longer just transport nodes. They are key actors in a global clean economy where decarbonization must be profitable. Moving on, figure 5.2 shows who is driving the agenda. You don't see one unified block, you see 4 specialized pillars. First, at the bottom right, we have operational efficiency anchored by IRIS. This is the first fuel school of thought, optimizing what we have before building what's new. Second, the energy infrastructure pillar, led by Feng and Pavitar. They argue that the port is transforming into an energy producer, a hydrogen hub for the hinterland. Thirdly, the scattered across the bottom, we have fuel mosaic analysts like Hoike and Gray. They provide the realism, analyzing safety and supply chain limitation. Finally, occupying the center is strategic logistics, represented by Song. This is crucial because it acts as the bridge. Song works on green shipping corridors, connect the technology to the market, moving the debate from can we do it to how do we recognize a correlation to get it done.
Assalamualaikum and hi, my name is Aizuddin Birohami. My matrix number is S71118. So now I will continue the presentation and will present the last part. So for the conclusion is decarbonization of port require integrating technology, policy and operation. While technologies like OPS and energy have measured challenge remain, especially in fuel acceleration and hydrogen storage. The research evaluations show movement to a clean maritime economy focusing on reshipping corridors and collaborative models. Achieving IMO 2050 goals require coordinated strategies among ports, shipping lines, and energy providers. So that's all from us. Thank you.